This video looks at the homework for Benninga Chapter 31, where we're using advanced data tables on an empty cell. I want to send a shout out of thanks to Jaron for pointing out an issue here where the way Excel calculates its data tables may not be quite intuitive to all of us. Certainly wasn't intuitive to me. This is Tariq's problem where he's flipping the coin 10 times with Boris, and we call that a game of 10 flips, and we want to simulate 25 games using a data table. And the way this was approached was, let's build a cell here that has a coin flip. We're used to that formula. If I hit F9 a few times, that coin flip can result in 0 or 1. And it's logical, well, it's not going to work in this problem, but it's logical to come down here and build a data table. Point this at an empty cell, and then we get 10 coin flips. Everything works great. In this case, he goes ahead and converts this to dollars of Tariq's winnings, and you can see that Tariq won $6, 6 out of 10 games there. If I hit F9, that time he won 3 out of 10 games, and then next time he won 7 out of 10 games. So every time I hit F9, I find out what his new game was, his new winnings for that round, that game of 10 rounds. So what you would think we could do is, again, use a data table to simulate 25 rounds, 25 games, let me say 25 games of 10 rounds each, and then see what the answers are. The problem here, if you try it that way, is all 25 give you the same answer. This is a problem because all 25 games should give you a different answer. It should be looking at this cell, hitting F9 25 times, and each of these different possibilities from, I guess, from 0 to 10 should get populated down here. But the problem we found was that the same number was populating this entire table. And let me tell you why. The way Excel goes through and calculates itself, it calculates all 10 coin flips, gives us an average, and then it's finished calculating this space. Now it's going to keep working down the page. Now it's going to calculate this data table. It's going to put that 1 over here. It's going to look up here, grab that average, put it in here. It's going to put the 2 up there, grab that average, and put it in here. The problem is that average is not changing because this is not getting recalculated. And that's why we get the same answer throughout the data table. It took a while for us to figure this out. So what we need to do to fix that is not use a data table up here. If you think about it, what we're trying to do this way is nest a data table. We're trying to make this data table run this data table to get that row, and then on the next row run this data table again to do that. And just think of it as Excel being too lazy. It's not going to run that data table every time. It says, well, I've already calculated that data table. I don't need to do it again. I'll just use the answer I got. Excel is not thinking that this data table is based on random numbers. So the short answer is, instead of having these numbers generated by a data table, we just want to take our coin flip formula, and now each of these numbers are generated by this rand function. So we're still getting 10 coin flips, we're just not using a data table to do it right here. We take the average of that, we come down here, and then this data table, which is looking at this number 25 times, now is giving us 25 different answers. And that's what we needed to get. We go on to do this 1,000 times. So let's come over here and copy this again. Point this to that, and I believe this is maybe problem 7-ish. So this is 7, A and B. We want to get the average and standard deviation of 1,000 games of 10 rounds each. So here we'll get the answer to be the result of 10 rounds, and we'll simulate 1,000 rounds. So let me copy this down to 1,000. Build our data table. Point it at an empty cell. And now we have 1,000 results of this 10-round game. We'd like to know what the average and standard deviation of those are. So the average and the standard deviation are Excel functions that we can use. Go ahead and use the sample standard deviation. It's going to be minuscule difference which one of those two we choose. And so we know what the average and standard deviation are for that 1,000 possible outcomes of this 10-round game. Those numbers should change a little bit if I hit F9. So now we have our answer 7A and 7B, and we can compare that to what we would have expected if we remember from statistics that the mean plus the standard deviation is a number we should exceed only about 16% of the time. It's asking us what percentage of our 1,000 realizations did Tariq win. So let's go see. So if I said mean plus 1 standard deviation, on average he wins a little less than $5 in those 1,000 plus 1.6. We should exceed that 16% of the time based on the properties of a normal distribution. And so let's see if we do. We want to count the number of these outcomes that are greater than 6.45. We need to put that in quotes. Would expect 160 out of 1,000 would be 16%. Let's see how close we get. 178, not bad. Now, this is not a formula, so if I hit F9, it's not going to fix it. Let's fix that. You can tell that COUNTIF is looking for a range and then some kind of a criteria in text. We can concatenate using the ampersand that cell reference, and what that gives us is the same thing, the count of these numbers that are greater than this number. So if I hit F9, we'd hope that that number kind of hovers around 160, and in fact it does. In fact, we could convert that to a percent by dividing it by the count of these. And I know you're saying, well, why don't I just divide it by 1,000? And you could. I'd rather you divide it by the count of those, because if you decide to run 2,000 iterations and you forget to change this 1,000 to 2,000, then you'll be messed up. But if we point them both at the same range, then this is a little bit cleaner. So let's convert that to a percentage and then hit F9 a few times to recalculate. And it seems to be hovering right around that 16%. Which is what we know from the normal distribution is the chance of exceeding the mean plus 1 standard deviation. We have 8A. We need 8B, which is what is the total amount of winnings does Tariq have a 10% chance of exceeding. Now, one way we could get that would be to copy these numbers, paste them somewhere as values, and sort them and take the top 10. But a much easier way to get to the top 10 is to use the percentile function. So let's use the percentile function to find the amount of winnings that we know we have a 10% chance of exceeding. There's always a question when you use these percentile functions, are we talking about P90 big or P90 small? So if we just take a guess and say percentile, I like to use the inclusive because that way if I happen to be dealing with the smallest number, I don't get an error. It doesn't affect the calculation much at all. So we'll use inclusive and take the array. So these are the numbers where we want to find the 10th percentile or 90th percentile depending on your nomenclature. So I'll type in percentile.inc, look at the array, and then tell it we want the 0.1 for K. And that tells us we have a 10% chance of exceeding 3. Well, there's a nomenclature problem here. Really, we have a 10% chance of being less than 3 and a 90% chance of being greater than 3. So we could come in here and say we really want 1 minus 0.1, or we could just call it 0.9. So whether you call it the 10th percentile or the 90th percentile, I guess depends on whether you're a glass half full or glass empty person. But you'll know it when you see it. And so we have a 10% chance of winning more than $7. And that makes sense. If you hit F9 over here 10 times, I'll bet it's greater than 7, maybe 1 out of 10 times. So I hope this video was helpful in helping you understand that we can't take a data table and run it multiple times with the data table. We have to build our model in a spreadsheet, get an answer, and run that multiple times with the data table. I also hope it was helpful in getting you to understand the percentile function, and I guess the average and standard deviation were probably pretty straightforward. Also, a new thing in this video is COUNTIF. So any further questions, holler at me.